Hey everyone, welcome back. Today we are going to go over Chapter 3. We're going to finish it up. We're going to focus on modeling concepts, those being operation features, with the focus on revolving and different sweeps. Remember, there are two types of features, those that are applied directly to our model versus those that are our sketch features because they need a two-dimensional sketch.
So if you've noticed in your SOLIDWORKS part document window, on your toolbar, you're able to see these different icons. So these will help you magnify or reduce the view of a model in your graphics area. The first icon you come to is your zoom to fit. It displays the part so that it fills the current window. Then next is your zoom to area. This zooms in on a portion of the view that you select by dragging a bounding box, and then it will zoom in. The third icon is zoom in or out, so you can drag the pointer upward to zoom in or drag the pointer downward to zoom out. Remember, you can also use the roller on your mouse. So if you roll it forward, it zooms in, you roll it backwards, it zooms out. Then we have the zoom to selection. So the view zooms so that the selected object fills the window. If you keep going over, you can see the different types of display options we have as well, which we'll go over in a little bit. So here are your display modes. It illustrates the part in a various array of display modes. So our first is just wireframe. So everything is outlined. You can see the back edge. The next we have hidden lines visible. It's kind of hard to see, but if you look really closely, you just see dotted hidden lines so that you're mainly focusing on the object lines itself. The third display mode is hidden lines removed. So now we only see those object lines. We don't see where that inside corner connects. The next is shaded with edges. This is the mode you're always going to use for your isometric views on your parts and your finished parts. And then the last is shaded. So we normally use hidden lines visible and shaded with edges the most. Here's a picture of your standard views. So you can see I have the isometric view up on the top left, and then I have a glass box which goes to our glass box theory down on the bottom right. I've put in the planes on this part so you know exactly what you're looking at. So we have our ISO view. To see the different height, width, and depth, you need all the views listed here. So you picture opening this glass box up. So we have our front view, our top view, and our right side view. That is what we work with the most. You can see that the bottom view is like the top but flipped. Same with the left view and the back view. Your view orientation can be changed to display the view or correspond with one of your standard view options. So we have our front, right, bottom, isometric, top, left, and back. And then we've used this a lot as our normal too. So you can select a plane or planar face and bring it so you're looking perpendicular onto it. So you can select any of these planes through those different displays. Here's just a slide that shows you when you're selecting the display icon what face you're going to be looking at. The views most commonly used to describe a part are going to be your top view, your front view, right view, and then an isometric view. You can take section views of your part. This helps if you need to display internal structure or mechanisms of your part or model. It does require a section cutting plane. If you did your tutorial 1, you played around with your section planes and section views. You can use any plane that we already have, the front, right, or top. You can also put in diagonal planes and create your own. Once you select the plane you want to take your section view cut from, you can use this inner arrow and zoom it in or out to control that depth of that cut. It is really nice if you're dealing with a motor or something and you need to see the internal gears and how it's working. So now we touch on our sketch features and operation features. These sound so similar, but keep in mind they are completely different. You will be tested on this, so this is a slide to remember. Your sketch features are going to be your shape features. They have sketches to create them. So your extruded boss, extruded cuts, they have to have that base sketch. Your sketch features are built from 2D profiles. So if we have a box, your 2D profile is the square or the rectangle sketch. Then you've extruded it. You can cut out a triangle or a square from that box as well. So those are your sketch features. They're listed here on our feature tree manager. Extrude one, built from a sketch. Now we have our operation features. They do not have to have a sketch. So these are chamfers, fillets, shells. They're applied directly to the workpiece by selecting your edges or your faces. They are listed as well on your feature tree manager, but you'll notice they do not have a drop-down arrow because there's no sketch needed to create them like there are for the extrudes. So keep in mind, a sketch feature has to have a 2D profile. An operation feature is just applied directly to the work. So focusing on operation features, let's talk about the fillet or a round. So they create rounded internal or external edges of a face of a part. It can remove or add material. If you're having an outside fillet, so a convex fillet, it removes material. If you're having an inside fillet or a concave, it will add material. Fillets are really good because you don't want a part built at strictly 90 degrees. You need some added material in that corner to provide strength. You just select the different edges you want to be rounded, or you can select the whole face, which it will round all the edges. And then you can specify what your fillet radius is. If you have too much material being removed or added, you'll have an error. So make sure you keep your fillets small. Then we come up with the chamfer. It's very like the fillet, but it bevels the edge rather than rounding it. It also can add or remove material. You can specify different angles and distance or length for this feature. So your features and commands are what you're going to use to build your parts. So here we have our base feature. It's just an extruded base feature to build this box. Next we have our fillet feature. We've rounded all the outside corners. Then we have our shell feature. We have cut into this box with the shell command, so all the wall thickness is the same. And last we have our extruded cut feature. So we have this hole on the side and it is cut all the way through. To create the extruded base feature for this box, you select the plane you want to sketch on, you sketch a rectangle profile, you would dimension it to the size you want and make sure you're connected to the origin and your sketch is fully defined. Then you'll extrude the sketch. By default, your extrusions are perpendicular to the sketch plane. Now to create that fillet feature, you're going to fillet the edges of the square. So you can select each edge. You can hold the control key down to select all 4 at one time. You then select your fillet command, specify the radius you want them to be, and hit OK. For your shell feature, you need to remove the material from the inside of this box. So you're going to select that top plane, select your shell feature, and specify your wall thickness. It will then shell the entire part from top to bottom. So even this bottom layer down here has the same thickness of material left in it as does the whole outside wall. To create the extruded cut feature in the box, you'll just select the plane you want to sketch on, so this outside plane. You will sketch a 2D circular profile. Remember, you need to have its size dimension, like a diameter of 10, plus its placement. Features need 2 placements if they have no relationships added to them. So we have how far it's placed from our bottom datum, and how far it's placed from our side datum. Then you will go to your extrude cut feature on your features toolbar. You can enter the condition through all, and then your cut will be cut through the entire part, so you don't have to sketch 2 circles. If you had interior parts or designs and that part could not be cut all the way through, you could specify the depth you want it cut, and then we could mirror it or drag it to this other face, as we'll talk about. I kind of touched on this in class, but the rollback bar, you can use the Feature Manager rollback bar to temporarily roll back to an earlier state. You can add new features or edit existing features while the model is in the rolled back state. Just drag the bar up or down in the Feature Tree Design Manager to step forward or backward through your regeneration sequence. It affects the feature order on a model and the parent-child relationships. So you can't have your next relationship without the beginning. Like you can't have a child without the parent. That's why we focus on that parent-child relationship. So make sure if you do not want a feature that you suppress it. If you're dealing with an extrude or a feature that's built off a 2D profile, you need to suppress the sketch as well, or you will keep getting an error. Our parent relationship is always listed above in our Feature Tree Manager compared to the child, which is listed below. The child is a derived relationship from the parent. So when you're editing your feature properties, you need to think about the difference on how you're going to approach your design. So if we started with our box for both of these examples, and then we shelled it and then created a hole, we'd have what we see in A. A whole shelled box and then that whole extrude just on the bottom. Now if we did it in a different order but used all those same features, so we started with our box, but this time we created a hole on this top plane and extruded it and then shelled our feature, you're going to see that same shell wall thickness around that whole extrude too. So keep in mind how you want to design your part, and that will depend on how you're going to approach it and build it. Sweeps. I want you to know that in SOLIDWORKS the linear sweep is called an extrude and the revolve sweeps are called revolve. So the more general sweep command is just for more complicated paths. In the book we talk about the different kinds of sweeps and using different techniques. So we'll talk about sweeps and revolves in this course. So your revolve feature, you guys all worked on this in your Chapter 3 homework. It is created by rotating a two-dimensional profile sketch around an axis of revolution. The profile sketch can use a sketch line or a center line as the axis of revolution. The profile sketch cannot cross the axis of revolution. So thinking back to your Chapter 3 homework, I told everyone just use the outside edge. It has to be one of the outside edges, so it could be this edge or the side edge. If I chose the smaller edge, then my center is going to be hollowed out. Now, if you need a hollowed out space, but you want it the length of your whole part, you could insert a center line and create an actual distance, so a dimension between that center line and this edge, and set that dimension, then rotate around this center line as your axis of revolution, and this part now would create a hollow hole in the center of it right here. So you can use the outside edge or create a center line and use that as your axis of revolution. So to create your revolve feature, you want to select a sketch plane, then sketch your 2D profile. Make sure it's fully defined, so we have all our dimensions plus relationships in this profile. You can put in a center line or just use the outside edge as your axis of revolution. It has to be within the same sketch and cannot be in a separate sketch, and it cannot cross into the profile. So you would click your revolve Bosch/base icon, specify the angle of rotation. Default automatically comes in at 360 degrees. You'd select that line or axis of revolution and hit OK. Now your sketch is revolved around the axis of revolution, creating your feature. So it's much easier to create a two-dimensional sketch and then create this 3D revolve feature than trying to sketch this and cut down from a basic block. Now for a sweep feature. A sweep is going to be created by moving a two-dimensional profile along a path. So we're going to practice making this candlestick for our lecture work assignment, and you're going to use your sweep feature for the handle. A sweep feature always requires two sketches, that being a sweep path and sweep section. This can be confusing because you will be sketching on two different planes. Where you revolve, you had your one sketch and you're revolving around its edge or a center line within the same sketch. Now we're going to create two different sketches on two different planes and connect them together. So here are some rules of your sweep. The sweep path is a set of sketch curves contained in a sketch, a curve, or a set of modeled edges. The sweep section must be a closed contour. The start point of the path must lie on the plane of the sweep section. The section, path, or the resulting solid cannot be self-intersecting. So you want to make your sweep path first and then your section. Create small cross sections away from other part geometry. Then move the sweep section into a position by adding coincident or Pierce relationships to the end of the sweep path. These are just some general overview tips. So to start, we're going to create our sweep path. So you can see we have a straight line segment, then we have an arc connected to another arc. So you're going to sketch on the front plane. You're going to sketch this line and tangent arcs, add in your dimensions and relationships it shows. This 10 is how high up our path is going to go from our bottom datum. Then you will close this sketch. Remember, you have to have a different sketch open for two different sketches. So now you're going to sketch on the right plane. So select the right plane, open up a sketch, and this time you're going to sketch an ellipse. Add in your horizontal relationship and your dimensions. Once you have it defined just somewhere on the right plane in your part document window, then you want to add a coincident relationship between the center of the ellipse, like right here, and that endpoint of the path you created. This will connect the two, and then it will snap your ellipse and it'll be fully defined because it's no longer just floating in space. You already set the dimension for where your path was going to start and end. And then you'll close the sketch. Now we're going to sweep the handle. So click your swept boss/base feature. Then you can select your sweep path and your sweep sketch section. Make sure they're both selected and hit OK. You can also make sure you have selected both the path and the section, and then click the swept boss feature and it will automatically come up as well. Here is the results of sweeping your candlestick. So everything's connected and it has a nice path. So pretty much you want to keep it simple. You don't always want to use a sweep feature when a revolve or an extrude will work. Sweeping a circle along a circular path appears to give the same result as a revolve feature. However, the revolve feature is mathematically less complex and it's easier to sketch because you're dealing with one sketch versus two. With the revolve, you're having a circle that you've dimensioned and then you're moving it in a path around your axes. With your sweep, you're going to have to create that path, which is the circle around, plus your profile, and then sweep it. So just keep it simple. Don't try to overdo it with your parts. Remember, if you have any questions, please email me. Look for your assignments and your lecture work. We are doing the candlestick tutorial today, so let me know if you have any questions on that. I hope you enjoy it. It's my favorite tutorial.